Hello everyone, today we will discuss about UV spectra of different molecules. UV spectra represented by a graph of molar absorptivity and wavelength. In this diagram, we show acetone in hexane. Lambda max value for this solution is 279 nanometer. These are some examples. For example, if non-conjugated alkene, it show intense absorbance below 200 nanometer. For example, ethene. Ethene show lambda max value at 175 nanometer. Here excitation of only pi electrons. Non-conjugated carbonyl compounds have very weak absorption band in 200 to 300 nanometer region, and here excitation of non-bonding electrons. Acetone show lambda max value at 279 nanometer, and cyclohexanone lambda max value is 291 nanometer. Next is two or more non-conjugated double bonds. UV spectrum is same as simple alkene. If there is non-conjugated double bonds, then these two separate double bonds show excitation at simple as a simple alkene. For example, 1,5-hexadiene lambda max is 178 nanometer, and for ethene it is 175 nanometer. If double bond in conjugation, then lambda max also increases. For example, 1,3-butadiene lambda max value is 215 nanometer, and for benzene lambda max is 257 nanometer. Carbonyl group and double bond in conjugation shift the lambda max of both to longer wavelength. For example, carbon-carbon double bond, for this diagram, carbon-carbon double bond has lambda max value at 230, and for this carbonyl group show 327. Some important terms used in spectroscopy. Chromophore. Chromo means color. Chromophore may be defined as any covalently bonded group that gives a characteristic absorption in UV or visible region. It may be impart color or not, which are not in conjugation with other group. Next है chromophore are of two types. Chromophore which contain pi electrons undergo pi star transition, and chromophore which contain both non-bonded and pi electrons undergo pi star transition and non-bonding pi star transition. For example, carbonyl group, azo group and nitro. Oxochromes, these are the group which do not show any characteristic absorption above 200 nanometer, but when attached to a chromophore, it shifts the absorption towards longer wavelength along with an increase in the intensity of absorption. These are called oxochrome. Oxochromes are also called color enhancing group. It brings red shift, it means to the longer wavelength. For example, OH, OR, NH2, NHR, NR2, SH, SR. For example, we compare benzene and aniline. Benzene show lambda max value 256 nanometer. Aniline, it increases up to 280 nanometer. And value for Emax is 204 for benzene and 1430 for aniline. Reason: Oxochrome shows this effect due to its ability to extend the conjugation of chromophore by sharing non-bonding electrons. Here we transfer non-bonding electrons of nitrogen to next and pi bonding electron to the carbon. Here this show conjugation. Extending conjugation has reduced energy gap between pi and pi star, that is exert bathochromic shift. This is the diagram which show these effects: hypsochromic shift, bathochromic shift, hyperchromic shift and hypochromic shift. Bathochromic shift, it is also called red shift. Shift of absorption maxima to the longer wavelength is called bathochromic shift or red shift. It is done by three methods. First, attaching oxochrome to carbon-carbon double bond or benzene ring. Here we show the example of benzene. This is simple benzene and next is aniline. Here NH2 group is attached to the benzene and here OH group is attached to benzene. If simple benzene, then lambda max value show 203 or 254 nanometer. For aniline it is 230 or 280. These show primary or secondary absorption. And for alcohol group it is 210 to 270. And for lambda max there is E max value for benzene 7400, for aniline 8600 and for alcohol phenol it is 6200. Greater the availability of non-bonding electron, greater will be the bathochromic shift. For example, oxygen is more electronegative than nitrogen. Therefore, lone pair of electrons for nitrogen is more easily available for interaction with pi electrons. Hence, bathochromic shift is more in aniline than phenol. Second is conjugation of two or more chromophore. For example, ethene or 1,3-butadiene. Ethene lambda max value is 175 nanometer. Butadiene it is 217 nanometer. E max value for ethene is 15,000 and for 1,3-butadiene it is 21,000. Third is by decreasing polarity of solvent. Transition of electrons non-bonding to pi star. Acetone, in case of acetone 264 nanometer in water and 279 nanometer in hexane as a solvent. Hypsochromic shift or blue shift. Shift of absorption maxima to shorter wavelength is called hypsochromic shift. It can be done by first by attaching oxochrome to CO group, then non-bonding to pi star absorption undergo hypsochromic shift. For example, acetaldehyde lambda max value is 293 and E max value is 12. Next, if hydrogen replaced by chlorine, then lambda max value is 235 and if it is replaced by amine group, then it is 214 and if it is replaced by OH group, then it is 204. Because negative inductive effect of heteroatom withdraws electrons from the carbonyl group. Therefore, lone pair of electrons on oxygen atom held more tightly thus becomes difficult to excite, require more energy, then it undergo hypsochromic shift, that is towards the lower wavelength. Second, by increasing polarity of solvent, for example, acetone appears at 279 in non-polar hexane as a solvent and at 264 in polar as a water solvent. Third is hydrogen bond can also shift to the shorter wavelength. Next is hyperchromic shift. Increase in absorption intensity is known as hyperchromic shift. This is due to some addition of some oxochrome. Next is hypochromic shift. This means decrease in intensity of absorption due to introduction of a group which distort the geometry of the molecules. For example, in aniline, if one proton is added to this lone pair site, then Emax value decreases from 1430 to 169. And in biphenyl and 2-methyl biphenyl, it is value of Emax is 19,000 and it decreases to 10,250. Thank you.